So I know what you're thinking. Well, we've had a lot of fun. We've looked up the scale of the universe, we've researched scientists which inspire us, we've even had a lot of fun with significant figures in scientific notation. But this is chemistry class. When are we going to start experimenting? Well, not yet, but it is going to be soon. We have just a little bit of safety and procedure to go over first. Okay, first though, I want to take a look at some of the equipment that we'll use in labs. First, let's start with things that we're going to measure with, because chemistry, we do need to be very careful with our measurements, and there's a lot of different things to choose from. So let's make sure we choose the right instrument for the right job. Graduated cylinders. The majority of your liquid measurement will be done with these. The thinner they are, the more precise they are. When you are measuring with graduated cylinders with liquids, you're always going to want to measure from the meniscus. Due to the nature of water and the hydrogen bonds it forms, it's going to not go straight across the edge. It's going to swoop down. You want to read from the bottom of that swoop. We'll check that next time in class. A beaker. Beaker is great for storing things, not so great for accurate and precise measurements. You do not want to use a beaker to measure, say, 100 milliliters of water. Even though there's a line there, you're going to want to measure with a graduated cylinder and then pour that into a beaker. Here is an electronic balance. These can measure down to 0.01 grams. They're very useful for measuring small amounts of chemicals. It is very important to keep these clean, as if you get chemicals underneath that metal tray you see there, it can really break the machines. We'll practice that in class too. An older form of balance doesn't mean it's not good. A triple beam balance. This is going to be used to measure some things that we don't maybe need to measure as precisely. You probably have used those in middle school before, but we'll refresh that as well. Erlenmeyer flasks. Also not great for measuring out amounts of liquid, but good for holding liquids. The markings on the sides are to be used as an estimate, not as a precise measurement. This is a pipette you see here. A pipette, sometimes they'll have graduations, markings on the side that help you tell volume, sometimes not. If we need to measure out a drop of something, a pipette is a great tool for that. Other things you might use in the lab. This is a Bunsen burner. It makes a flame. You can control the amount of gas flowing in and the amount of oxygen to make a cleaner flame. This is a hot plate. If you need heat without the flame, the hot plate is the choice for you. It's like the difference between a gas stove and an electric stove. This is a crucible. It's made of ceramic. Things are heated in it. We will do some labs involving these. They are breakable, but they don't shatter when you apply flame to them. Shown here on the right is a ring stand. You can put a crucible supported on what's called a clay triangle on top of one of these and supported above the flame. We will be using these this year. What you see in the picture now is called a burette. A burette is used for measuring very, very precise amounts of a liquid for a type of reaction called a titration. That's going to be done with acids and bases. We'll get to those near the end of the year. One of the great things at the science department this year, thanks to a generous donation from parents at the Savio Soiree last year, is that we have a lot of electronic probes. These all connect together through the Vernier LabQuest. It's a wireless color touchscreen device that you can plug any number of probes into and measure all sorts of things about the world. In particular, we'll be measuring pH, we'll be measuring gas pressure, not so much force, but we do have force measurements. Let me go back real quick because there's a lot of other things we can measure too. There is a temperature probe connected right here, works just like a thermometer. We can measure radiation. We'll be doing that this year. We can measure ultraviolet light. You could measure speed. You can measure conductivity. You can measure again, almost anything you can think of, we either have the probe to measure it or we can get the probe to measure it. So I think it's going to be a lot of fun using these this year. Okay, there's a lot of common chemicals out there. There's some of them that you need to know. First, I want to talk to you a little bit about the dangers of one called dihydrogen monoxide. Dihydrogen monoxide is pretty serious stuff. If you breathe it in, it will kill you. When it's in its gas form, it can cause burns. In its solid form, it can cause tissue damage. It is a major component of every pesticide out there. It's a major component of acid rain. The oceans are full of this stuff, and yet no government on Earth will do anything to stop it. Pretty serious, right? Well, the more common name of dihydrogen monoxide is water. 2 H's, 1 O, H2O, dihydrogen monoxide. It's important in lab that we use distilled water because there's impurities in tap water and that can throw off our reactions. So we need to make sure we use distilled water, which is pretty clean. NaCl, sodium chloride, that's table salt. IPA, isopropyl alcohol, rubbing alcohol. Your parents might have it in the first aid cabinet. It's useful for cleaning things. HCl, hydrochloric acid. It's a strong acid. It's probably the most common acid we'll use this year. One of the most common. Sodium hydroxide, it's a strong base. Basically drain cleaner. Also pretty powerful, common stuff. Sodium bicarbonate. That's baking soda. Acetic acid, that's vinegar. All pretty common stuff here that we will be using this year. So the lab station, there are 10 lab stations around the room, which means depending on whether you're A or H block, you may have 3 people in your lab group or 2 people in your lab group. The lab drawers are just absolutely packed full of useful stuff. Sister Mary Elizabeth did a lot of work setting these things up over the years. You're going to have 6 beakers of various sizes, 2 graduated cylinders, a spoon for measuring chemicals, a stir rod, that's a small glass rod used for mixing a reaction. You're going to have a plastic cup, a plastic dish, markers for labeling stuff, always important that you know what is in what beaker. Isopropyl alcohol for washing down the beakers, that removes the permanent marker like that. It's very easy. You'll have rings and a ring stand. You'll have tongs. You'll have pH paper. We probably won't be using that as much this year. Distilled water, a heat-resistant pad, just so many things. It's very useful, and they're all labeled so you'll know how to get them back in your drawer because the drawer will have the same number as the material on them. Very important to do that. So when you measure in the lab, and again, we will practice all this stuff in class, important things to know, read in between the markings on a ruler. You want to estimate the in-between parts. Read at the meniscus, that's the little swoopy down part for liquid measurements. Use the most precise method possible. Again, you're not going to use a beaker to measure liquid, you're going to use a graduated cylinder, or something even better. Clean up after yourself when you measure. If you spill, even if it's water, even if it's salt, clean it up right away, because someone else will come along, they're not going to know what it is. Maybe it's salt, maybe it's something that could kill them. Maybe it's water, maybe it's hydrochloric acid. Clean up after yourself. Take only what you need. Don't take more than what you need and then put it back. We're never going to take something that we measured out of a bottle and put it back in the bottle because it may be contaminated and that can mess up other people's labs. Safety. Next time in class will be almost entirely about safety, but a few rules, very important, that we should go over. You're going to wear gloves. Anytime we use chemicals, you will be wearing gloves. But you brought gloves in. They'll be fine. We all have them. Goggles. We provide the goggles. Some schools don't. We do. These are going to cover your eyes. They're not safety glasses. They wrap all the way around your face. They'll protect you from splashes. An apron. This is going to keep your uniform nice and clean so that you don't accidentally spill something on it. So your eyes will be protected, your clothes will be protected, and your hands will be protected. Wear closed-toed shoes. Shouldn't be a problem because the uniform doesn't have open-toed shoes, but closed-toed shoes will keep things from being dropped on our feet and possibly severing a toe. No horseplay. You should never be horseplaying in a class anyway, but especially during lab, do not horseplay. Not around possible flames and dangerous chemicals. Do not touch anything until you receive instructions. Have a plan of action. Know what you're going to do before you start touching stuff. One person per group, if materials are at another station, should go and grab them. That way we don't have 30 people trying to crowd around one station. Do not touch, smell, or taste any lab materials. On occasion, if something needs to be smelled, we may waft it. That's when you use your hand to bring the scent towards you. Never put your face directly above a beaker. Some terms that you should know while we're doing labs. A reactant is an ingredient, what you start with. A product is what you end up with. Like in a recipe, if you make a cake, the cake would be the product. Procedure, this is what you are going to do. Code 1, this is what you need to say if there is an accident in the lab and you need my immediate attention. Don't be the boy who cried code 1. All eyes. If you hear me call for all eyes, you need to stop what you're doing and look at me. I have some important instruction to give you. I want to talk a little bit about safety labeling. We will go over this in class too, but safety labeling has undergone a major change over the last year. We're now using a lot of people in the world are using the Global Harmonized System, GHS. This is new international standards for chemical safety labeling. Everyone's going to be using the same thing. That way there shouldn't be as many confusions. And one of the major parts of GHS labels are these pictograms, these little diamonds with different pictures in them that are useful for quick identification of hazards. If you take a look, oxidizers, these can make things burn better. Toxic to aquatic organisms with the dead fish. Explosive. Flammable. Gas under pressure, so it might explode. Irritant. Corrosive. Toxic to humans, even with small amounts. It's the poison symbol. And health effects, although that looks to me like it makes you a superhero, but it's bad, not good. If you see these symbols on a chemical that we're using, you'll know to be extra careful and we'll have special precautions. Where will you find those precautions? In an SDS document. This stands for Safety Data Sheet. They used to be called Materials Safety Data Sheet, but they got rid of the M to make it easier to say. The picture on the right is still a Materials Safety Data Sheet, but it's basically still the same thing, just under a new name. In class, we will go over how to read these things. There is a website here that you could go to if you want to just Google how to read an SDS and then type in Flynn, F-L-I-N-N, as you see up there. It will take you to a very good document that explains everything on them. We'll read a few sample ones in class, including water and concentrated hydrochloric acid, just to understand how to do that. And every time that we do a lab, we'll look at the safety data sheets before we begin. Where would you find a safety data sheet? Well, you can find them through a Google search, or you can come see me. As a member of the science department, my job is chemical safety officer. So one of my jobs is to make sure that all the chemicals are stored appropriately and that we have a printed out safety data sheet for each chemical we have in the storeroom. So I know where all of these are. If you're curious about anything, you can come see me. We're going to stop there for today, and we will go over in class how all of these things are going to work. We'll practice them, we'll see some safety videos, we'll take a safety quiz. You may want to look over the Flynn safety contract that you signed just to prepare. Great, thanks for listening.